Alright, so first let's review. So what we're going to do is we're going to turn these gene expression ratios into log base 2 gene expression values, and I'll tell you why we do that in a second. But part of the reason is to find the correlation coefficient. But first, let's talk about these gene expressions. So last section you looked at the gene expression and we looked at the colors. Alright, so in the colors we had red, yellow, green, and black. And then remember, we can transfer those into numbers as ratios. So if it's more expressed in, it's very, very dark red, it's going to be a high expression ratio. So this one would be very dark red. This is going to be an oncogene that's going to be pretty much always turned on in cancer and almost never turned on in tumor in normal cells. Whereas this one is only slightly expressed. It's closer to 1, so it's going to be a very light red. So this one is a little bit more on in cancer cells, but not quite on as much in normal cells. And then that's the same that goes from here. This one's kind of in between these two as far as how much is expressed in cancer cells. These are all expressed slightly more in cancer cells. And then these, because they're under 1, so 1 would be there be equal expression in both cells. And then this one is going to be the tumor suppressor because they're expressed more in the normal cells than the cancer cells. And this one's going to be your darker green because it's a lower number, or a higher fraction, whereas this one is going to be a this one's going to be closer to your not as expressed, so this will be a lighter green. Alright, so now we're going to have to graph these, so I'll just show you how to do that, and then I'll show you how to do the log base 2. So you're going to highlight all your points, go to scatter, and click the smooth line scatter. Now, the problem is it automatically took us graphing the patient's data. We don't want to know how the different genes are going in each patient. We want to know how each gene is, what's the pattern of each gene across the patients. So what we have to do is click the switch plot button up here, and that will change our data. Now it's by the genes, and the patients are down here. Gene expression ratio is still over here. So to finish your graph, you have to put in your title and your axes. This is how you put your title on. This is how you put your axes on. Alright, and I'm not going to do it, but you guys can easily put your axes. Remember this patient's gene expression ratio, and then just put your title. And the patient's, you don't have to change your axes, even though it's a little weird, but it's 1, 2, 3. Alright, so now how do we do equations in Excel? So really you could put in a calculator and do the log base 2 if you wanted to, or you can press equal sign. So whenever you want Excel to do an equation automatically for you, push equal sign. To do the log, you have to press log. Then you put parentheses, and then you put the numbers that you're going to take, what calculation what numbers you're going to do. So I'm going to click this number, and then since we want it in base 2, we have to put a comma and a 2. Close our parenthesis and press enter. And there's our calculation. Excel did the whole calculation for us. We didn't have to do anything in the calculator. So over here we can do the same thing. Log, parenthesis, click there, comma, 2. Alright, now there's a shortcut that we can do this for. If we put our little plus, our little cursor here, and down here at the bottom, we can click and drag, and it will automatically do the same equation for us here. Click here, click, drag, same equation with the opposite numbers. So if we click here, we see that it took C3, which is what we wanted, and the base 2 of it. Alright, so now let's just do one more. Log, parenthesis, click here because we want to find the log of 0.5, base 2, parenthesis, -1, and then just go down, and we now have our gene expressions in log form. Now I'm going to highlight these, and I'm going to graph them again, just like we did the other one. So we're going to have two graphs. And again, we're going to have to change the axes. And there we go. We have our gene expression ratios as log base 2s. Now, the reason why we do this is because look at the pattern here. Now our tumor suppressors are all negative, so it's a lot easier to see on our graph what our tumor suppressor genes and what our oncogenes. Our oncogenes are all positive. Alright, so it's a lot easier to see the difference of graph. Plus, we're then going to use these numbers for our calculation of correlation coefficient and see what kind of pattern we have between these genes.